Hello and welcome to a new very interesting video. In this video I will tell you what capacitor leakage means because this is something you encounter when replacing old capacitors like this. And I will tell you a bit more what it means, how it can be measured, and I will also do a second part on replacing such old capacitors, in which I will tell you what this marking here on this capacitor and what this marking here means, because actually old capacitors like this, or this type of capacitor, they are not polarized. There is no plus and minus like an electrolytic capacitor, but they still have this marking here, and this has something to do with the outer foil of the capacitor, with the shielding of the capacitor, and it can be important. So I will do a second part in which I will tell you what this means. But now back to the leakage thing. Currently I repair this device here, and this device is actually a capacitor leakage checker. It's more than just a capacitor leakage checker tester. It's a capacitor checker made by Heathkit. It's the model IT11, and this thing can measure capacitance, it can measure resistance, it can also measure inductance if you have a reference inductor. It's based on a Wheatstone bridge to measure capacitors, so it compares a known capacitor with your capacitor which you like to test. But the most important function of this device, and this is why I purchased it and why I restore it, is that it can test capacitor leakage. And but at the moment this thing has a lot of leaky capacitors in it. So this capacitor tester has leaky capacitors, and now I will tell you what this actually means. So before I start probing around and start measuring stuff in here, I will show you what capacitor leakage means and how you can test it. So actually I already mentioned it in a video which I did, that you can have two properties of a capacitor which degrades the quality of the capacitor. One thing is ESR. This is an AC thing. Basically, if the capacitor is operated at higher frequencies, it acts like a short, and then you have a resistor in series. But this is not the topic of today. The topic of today is the leakage thing, and this capacitor leakage is actually modeled with a resistor in parallel to your capacitor. Alright, so this means that there's a parasitic resistance in parallel of your capacitor. And this is tested not in AC, it's tested in DC. Because if you apply a DC voltage across the capacitor, then it will just charge, and if it is completely charged, then it would have an infinite resistance. But since this leakage is there, the resistance when the capacitor is charged isn't infinite, and there will be a little bit of current, or maybe a little more current, and this situation can be troublesome because first of all, there's power dissipation in the capacitor. If it is a filter capacitor, then it loads your power supply more than it should, because it's like a load resistance in parallel. And if it is a decoupling capacitor, this means that if there's one stage and on the other side is the other stage, and this stage, for example, needs to have 0 volts because it's the grid of a tube and it's pulled down with a 1 meg resistor, and the other side has, for example, 100 volts of it on it, and if this resistor leaks, then it could happen that the grid gets positive voltage, and this could cause trouble, because then you have excessive current flowing through the tube and to the grid, and therefore you can destroy your tube. So it is important that you can check this leakage, and it is important that you replace leaky capacitors, because leaky capacitors can be highly dangerous, and they can be highly dangerous so that they can destroy your device which you are repairing. Okay, so let's have a closer look at the real thing. So now back to the capacitor leakage tester with leaky capacitors. So how does this thing actually work? So the indicator for leakage is this here, or actually this here, this eye tube. It sits in here, and I've removed it for cleaning because it was extremely dirty, and it is important that it is clean because otherwise I cannot see the indication. Actually it was as dirty as this tube here. As you can see, it's very dirty, so I have to clean everything inside here, but this is the most important thing to clean first, because otherwise I won't see it very well. And now the question is, how does this thing checks leakage, or how should it check leakage? Basically you have this function switch. Here now we are in the bridge mode. This is for measuring capacitance values or resistance values, and if I put it down here, now I'm in the leakage mode. And if I have connect the capacitor down here, then it will apply a voltage on the capacitor. It will connect the voltage to the capacitor, and you can select this voltage with this knob right here. It starts by 3 volts and goes up to 600 volts. So an important thing with this is that if you have a capacitor, for example, rated for 35 volts or so, that you don't exceed the voltage of the capacitor. So in the case of 35 volts, you don't go higher than 25 volts, of course, because the next range would be 50, and then you would destroy your capacitor. So this makes no sense to check it. So check it only with a voltage at which it is rated. So you put it into leakage, then you select the voltage, and then this device will measure if there is a tiny leakage current flowing, and will indicate if this is the case with this I-tube right here. So, and after the test you put it into discharge, which is important because there can be dangerous voltage on it, and then the leakage test is done, and of course put it back into the lowest voltage position. Okay, but now let me show you some leaky capacitors in this device. Actually, this is a very good example. It's a good example that this leaky capacitor checker has leaky capacitors in it. Here on this side, these are the main filter capacitors for the power supply of the capacitor checker. They are rated for 350 volts and they are connected in series. And I think they are on 600 volts, but in series, so the 600 volts would split to 300 volts each of the capacitor. And to check a capacitor in circuit, to make sure that nothing is distracting your meter, it's always a good idea to disconnect one side. So I have removed this wire on this side here, so this capacitor is now completely open on this side. It's only in circuit on this side right here. This side here, it's open, and therefore I can measure it without anything else distracting the values. Actually, if you have tube equipment like this, it's much easier to make in circuit measurements, because if the filament of the tube is cold, then it is not conducting, and therefore many components are just like open on one side. But if you want to be really sure, then disconnect one side. So, and now I will show you something very interesting. I will use my multimeter to check this capacitor, and let's see what we get. So I will put my multimeter right here. I turn it on. Let me readjust the camera a bit, like this. Okay, pretty good. And now let me put it into the capacitance mode. So there we go. And now let's see what we get. Okay, so now it's in nanofarad. So what we expect is actually it's 40 microfarad, because the capacitor is rated for 40 microfarad. You can see it here and here. So now I will check my capacitor, and if I connect the minus lead here and the plus lead here, and if we look at the multimeter, then you can see it's auto ranging. And what do we get? We get 89 microfarad. That's interesting, because this capacitor is rated for 40 microfarads. So this means that it has more than the double of the rated values. That's strange. How could that be? Because that would be a high tolerance, and it would be a really big overachiever, actually having the double of the capacitance at which it is rated. And this is actually a strong indication that we have a leaky capacitor here. Okay, because the way how this multimeter tests the capacitor is, and how many other test devices for checking capacitors, is that the multimeter tries to charge the capacitor, and then it measures the time it takes for charging up the capacitor. And if the capacitor has a higher capacitance, then it takes longer to charge. If it has a lower capacitance, it does not take so long. And so therefore, by measuring the time, it can measure the capacitance. But now remember that if the capacitor is leaky, if it has this parallel resistance, then the current does not only flow through the capacitor, it will also flow through the parallel resistance. And therefore it also takes longer to charge the capacitor because the current flows through this resistor. And therefore this meter will read a higher capacitance value if a capacitor is leaky compared to a capacitor which is not leaky. So this is for me a very strong indication that we have a leaky capacitor right here. Okay. Now how can we measure this leakage? Actually with a meter like this, which I currently repair, which is this leakage meter. So now let me show you how leaky these capacitors actually are. So let me show you if I'm right with my assumption that this reading of more than 80 microfarad means that this thing is leaky. So let me configure a little test setup for this, and let me show you how this is. Alright, so here I've prepared a little test setup for you to demo the capacitor leakage. So actually I've hooked up the capacitor to this power supply here, to this high voltage power supply, which is off at the moment. So it's on but the output is off, and here you can see the output of the power supply, and it runs down here to a series resistor. And after this resistor we have a multimeter, actually this tabletop multimeter, which has a very high precision, and of course it goes extremely low. This multimeter is now set to current to measure the milliamps. Actually it measures down to microamps because here we have the dot, so these are microamps here. And then the output of the milliamp meter goes back to the plus to the capacitor, and then the minus of the capacitor goes back here to the power supply. Okay, so this is how the setup is. And actually what would we expect if I turn on the power supply? Then the capacitor will charge with DC voltage, and if it is completely charged, then no more current will flow because a charged capacitor acts like an open circuit. But if the capacitor is actually leaky, then we have current flowing through the leakage resistor, and therefore the current will not go down to zero. Okay, so let's do this measurement. But before doing that, a very important note. This can be highly dangerous because you're working with high voltage and maybe broken capacitors. So basically the capacitor could explode, the power supply could explode, your device on the desk could explode, your multimeter could explode, everything could explode, even you. So be very careful by doing it, or just watch me doing it, and you can do it with a proper test device like this. So this is just for demonstration purposes. So if you do this, you follow along. If you follow along, you're doing so at your own risk, of course. And it's also very important to have this resistor here in series, because if the capacitor actually fails and if it has actually a short, it prevents from excessive current flowing through it, and hopefully it prevents it from exploding. Alright, so let me put the camera back on the tripod, and then I will turn on the setup and show you what it does. Alright, so there we go, everything is prepared, the power supply is still off, the meter is reading almost nothing, which it should. And now let me set the voltage quite low, let me put it to 0, now I turn on the thing. And now let me increase the voltage slowly. I go up to 50 volts. And we would expect the capacitor to charge, and as you can see, the current also goes down. So we have 700 microamps, 600 microamps, 500 microamps, 490, and so on. So the current is decreasing because the capacitor is charging. Okay, so now let me switch to the next higher range of the supply, and we are now at 100 volts. So the current has jumped up for a short time, and now it's still decreasing because it is charging. Okay, so now we have 2 milliamps and decreasing. So now let me go up even further. Now we are at 150 volts. Okay, the current still is decreasing, but quite slow, as you can see right now. And now let me go up to 200 volts. 200 volts. Okay, so now we are at 200 volts and we have 9 milliamps. And as you can see, the strange thing now is that the capacitor, the current is decreasing, but extremely slow. As you can see, it decreases extremely slow. And if we wait some time, we will see if it goes to zero or if it settles. So now I waited a bit, actually a couple of minutes, and it is still at a high milliamps reading. It is still at 5.25 milliamps. But it's still decreasing, so it's reforming a bit, but it's still highly leaky. So this is not what it should show. Actually, now it should have been already charged, and it should be very down in the least digits of the multimeter, and not that high, not 5 point something milliamp. So I'm pretty sure that if I would remove the safety resistor, then we would have almost a short or a very excessive current draw. Okay, this was the test of the leaky capacitor, and it is now safely discharged. And now let me show you a good capacitor. So this is a new capacitor. It has 22 microfarads, so it's only half of that, but it goes up to 450 volts. And this is a new one. It will charge a bit quicker because it has the half capacitance, but it will be a good example of how a good capacitor should look like. So now I will connect this capacitor to the test circuit. Minus, of course, to minus like this, and plus to plus like this. So now I've connected the capacitor, and let me turn on the thing. So here we are back at our power supply and multimeter. The good capacitor is connected to the circuit, and now I turn it on and I increase the voltage to 50, and I can immediately increase it to 200 because there's no danger. And look at the ampere meter. Now we are already down to 60 microamps, and immediately after charging it we are down to 60, and now we are below 50 microamps. It is still going down further. So this is a good capacitor. This is how it should look like. Almost no leakage. This is also what the capacitor tester will test. So now after a little bit it is down to 15 microamps and it's still decreasing. Okay, so now a little safety note here. Now this capacitor is charged with 200 volts, so this is highly dangerous. So I have to discharge it safely, and I can't do that by decreasing the voltage on this power supply, because if I decrease the voltage on the power supply, it will actually draw current and therefore discharging the capacitor. You can see it on the multimeter because it's negative for a short amount of time. Look at that, now it's negative because it's discharging. But I cannot guarantee you that every power supply does that. So to safely discharge the capacitor, just use a resistor connected in parallel to the capacitor to discharge it. Of course, disconnect power supply, connect the resistor and safely discharge it. These capacitors can be very dangerous when they are charged. Be sure to discharge them before doing stuff with them. Okay, so now I will have to replace these capacitors with proper capacitors, and of course I have to be sure that the markings, this plus and minus sign, which shows you the polarity, you have to be sure that you insert the capacitor in the right way, because if you insert an electrolytic capacitor in the wrong way, then it might explode or damage your equipment, and this is not good. But I have some other capacitors to replace, which you can find on the other side here, and these are this capacitor here, this capacitor here, these two here, and as you can see, they all have this marking, this here, this marking here, and if I zoom into the small ones, they also have this line on them. So this actually, as I mentioned at the beginning, means that this is the outer foil or the shielding of the capacitor. And the interesting thing is that if you have a new capacitor, like this, and you try to replace the capacitor with a new one like this, then they don't have this marking. And in the next video I will tell you why this marking is there and why it is necessary to be aware of that, and how you can find the marking on a capacitor like this here. And yeah, this is in the next video, so please subscribe, and in the next video there will be more information. Thanks for watching. Bye.